Okay, good morning, ladies and gentlemen. We're going to finish up our last section of the chapter here, 8.5 day 2. Actually, what we're looking at repeating decimals. And what we're going to do is we're going to rewrite them as an infinite geometric series so that we can find their sum. And if we find their sum, I guess that our sum is going to be written as a fraction. Kind of nifty stuff. That's today, 23rd. So when we're done with the lesson, you should be doing your 8.5 day 2 try on your own. Tomorrow's just chapter 8 review for our summative. And then Thursday, please make sure on Thursday you send either Mr. Myers or myself your 5.1 day 1, 5.2 day 2, and your 8.5 day 1, 8.5 day 2, and your 8.6 try on your own along with your summative review. And then make sure you complete your summative test in its learning. That test should be completed probably Thursday or Friday, because all that homework should already be done. And what we're going to do is, like I said, we're going to look at this and we're going to convert the following repeated decimals to fractions using the infinite geometric sum formula. The infinite geometric sum formula is the sum of the infinite terms equals my first term divided by 1 minus the common ratio, remember. Now that's actually from a couple days ago because we flip-flopped a couple lessons. Well, how are we going to do this? Well, first I'm going to get myself a little room here. Well, how do I write this thing how do I write the repeating decimal as a infinite sequence? Well, I'm thinking of this as 0.3 plus 0.03 plus 0.003 plus 0.0003 plus. I think you get the key there. And I don't need too many decimals. I should only have 3. But you see the issue of what's going on there. And if I see this as fractions, because, I'm kind of a fraction guy. You can use fractions or decimals, but our answer should be a fraction. I see this as 3/10 plus 3/100 plus 3/1000 plus ... That keeps going on. So I can see my G sub 1 equals 3/10 for the fraction guys. I can see R equals, well, what do I multiply this term by to get there? Well, check it out. They're adding a 0 in the denominator. I guess I must be multiplying by 1/10. So R is 1/10. Okay? So if I'm finding the sum, okay, the sum of those infinite terms is going to equal my first term of 3/10 divided by 1 minus my common ratio of a 10th. Well, that gives me 3/10 over 9/10. How do I divide fractions? We don't. We multiply by the reciprocal. So my 10s cancel. I get 3/9. Ooh, 3/9 will reduce to 1/3. Check that out. Isn't that kind of nifty? Hopefully you knew 1/3 repeating, or excuse me, 0.3 repeating was 1/3. But what we did is we wrote it as a number we can type into our calculator, okay? Each example, now example B is going to be a little bit different. Notice my 3 was repeating, and that's how I started to write my sequence, and I took my repeater and I kept adding it as a sum. So if I added all those decimals, I get what's above it. Well, B is just a skosh different here now. A skosh, yes, that's one of my favorite terms. Skosh is just a little bit for any of those that are wondering what a skosh is. But notice this time I have 0.24 is repeating. So I want to identify my repeating portion of my decimal, and then I'm going to write it as a series. Okay, so I'm going to say 0.24 plus. Well, now there's my next repeater, so that's going to be 0.0024 plus. There's my next repeating part, 0.00024 plus. You get the kick here? You get the idea of what's going on there. Okay, from here, it's just me. I'm a fraction guy. You can use decimals. I'm going to see this as 24 over 100. Okay, it's nice because all I got to do is shift the decimal. Yeah, I can reduce that fraction if I really wanted to. Okay. And then this is going to be plus 24 over a 1 with 1, 2, 3, 4 decimals on it. Plus, the next one is going to be a 24 with 1, 2, 3, 4, 5, 6 decimals. Each place is going to be 1, 2, 3, 4, 5, 6 zeros. Each decimal place is a 0. And, ooh, that's over 1,000,000. And what do I see? I see my G sub 1 is 24 100ths. I could see that as a little bit less if I wanted, and I'll tell you why I don't, but, you know, reduced, if I divided all this by 4, what do I get? I get 8/25ths, right? I get 8/25ths would be reduced, but I'm going to use the non-reduced here, and you'll see why, I think. What is my R value? Well, R, what does R equal? Well, when I'm looking at my denominator, the top stays the same. The only thing that happens is I'm adding 2 zeros every time. So that means I'm multiplying by 1/100. That's kind of nifty. And that's why, see, I'm seeing common denominators between the top and the bottom. That's why I'm leaving this here. But if you don't get it, you'll get it here pretty soon. So then the sum of my infinite series is going to be 24 over 100 divided by 1/10, or excuse me, R minus 1/100th. Well, that gives me 24 over 100. That's going to be divided by 99 over 100, because over here I got to get a common denominator. This is 100 over 100. I'm rewriting my 1, so I'm always going to get 1 less. And then that's actually 24 over 100 times the reciprocal of the bottom. And that's why I didn't want to reduce this guy up here, because it's canceling out for me quick. And then I see 24, 99. Ooh, 3. Each of these are divisible by 3. Okay, so if I reduce this by 3 over 3, what do I get? I get 8/33. There it is. 8 over 33 is, as a decimal, 0.24 repeating. However, I can't type 0.24 repeating technically into my calculator. Some teachers have told you in the past, well, just write a whole bunch of them and it'll do it. Now, it's going to get in there as a rounding factor, but what you want to do is you want to be able to type it in as a fraction so we know what it is, okay? How about you give this last one a try here once? All right, I didn't figure you'd get too far on this one. I could be wrong, but if you notice, we got to identify our repeating portion, okay? Our repeating portion is the 5s. So what I'm going to do is I'm going to think of this as, I'm going to pull the non-repeating part off, and I'm going to think of this as 2.7 plus 0.05555 repeating. And what I want to do, I need to find my repeating part. That is the part that is going to be written as my series, and I'm just going to ignore this beginning part, because now I'm going to say, oh, it's 2.7 plus. This is not my first term. This is going to get added to the end to where my first term is 0.05 plus 0.005 plus 0.0005 plus, and that keeps going on. What do I see? I see I add 1 0. So this is the sum that I want to see. That's my series. This 2.7 is added on after, okay? So I'm thinking about, I need to find the sum of this guy, that portion of it. So what am I thinking here? Well, I'm thinking my first term is 0.05. What is R? Well, if I think of this as 5 over 100 plus 5 over, well, there's 3 decimals, so that's 1,000, plus 5 over here, there's 4 decimals, so that's 1, 2, 3, 4, that's 10,000. What do I notice in the bottom? I'm adding a 0 each time, so R should be 1/10, okay? So this sum is going to equal my first term, which is 5 over 100. Ooh, now watch, I will reduce this guy, okay? Notice my G sub 1 as a fraction would be 5 over 100, but check it out. I'm going to reduce that one because now my R value is 1 minus 1/10, okay? And, well, I don't have to. I'm just going to leave it. No big whoop. So this is going to equal what? 5 over 10, or 100, excuse me, over 9/10. Well, that's going to give me 5 over 100 times 10 over 9, isn't it? And then as I'm coming through here, I can reduce that to a 1, and that's now a 10, right? I'm just hacking a 0 off. So what I get is I get 5 over 90. Does 5 over 90 reduce? 5 over 90 does reduce to what? 1/18th, I think. 90 divided by 5 goes in there once, gives me a 5, gives me 40, gives me 8. Yup, it's 1/18th. So 1/18th, don't forget, I can't forget this 2.7 plus here. Here's my repeating portion that I found. It's the 18th. And remember, I'm rewriting this whole decimal, 2.75555, 2.75, where the 5 is repeating. So now I got to put these two little rascals together. And I'm thinking of this over 1. Well, heck, to me, that's 27 tenths. Okay? It's 27 tenths plus 1/18th. And I could do whatever I want. You know, now I'm going to have to go back. I'm going to have to get a common denominator. Well, what's my common denominator going to be? Well, yeah, this is going to be, if I take this one times 9 over 9 and this one times 9 over 9, that's why I probably would not have reduced that one right away. I can see this common denominator faster. 9 times 27, that's going to give me 243 over 90 plus, what does that give me over there? That's bad math there, Kruger. That's bad math. I need a 90, so this gets multiplied by 5 over 5, excuse me, and that's going to give me 5 over 90. Well, that gives me 248 over 90. Well, what do I see? I see these things will at least reduce by 2. So this is going to equal what? 124 over half of 90 is 45. Well, that denominator is only divisible by 5, and 124 is not. Therefore, there is my repeating decimal written as a fraction. Okay, and I could take this and turn this into a mixed number if I wanted to. If I wanted to come back and I wanted to write that as a mixed number, it would be 2 and 34/45. From there, I would not want to turn that into a decimal. Why? Because we know it's a repeating decimal. So what we did is we converted this repeating decimal into a fraction using the geometric sum formula. Well, hey, that's kind of cool. You might have been taught how to rewrite repeating decimals as fractions a different way in elementary or probably middle school. However, this is a new tool in your tool belt. Hey guys, have a great day and thanks for playing math today.